Alright, guys, we'll be doing Leibnitz theory today. Hope everyone is there in the meeting. Alright. Okay, so what you are going to do is we'll go through this theory. So this is part 1. There will be also part 2. So that's what we'll do in the next meeting when we meet. Alright. So this is MA210. These questions have been coming like of this type, of this kind. So just know that after this video you're able to get, I don't know if it's 80 marks, something like that. Alright, this is MA210. And you look at Leibnitz theory. So this Leibnitz theory, in this part 1, it is of the product type. Alright, so shall we start? Okay, so when we say of the product type, suppose you are given a function like this. Alright, suppose you are given a function to say y, is equals to u v. So this is a product, a function of two types. Let's say of x times z cos something, you get, or exponential times everything like that. So it's of the product type. So if you want to differentiate this one, you differentiate using product tool. So when you're studying this actually Leibnitz theory, we have we take in consideration to say we know quotient rule, product rule, mostly product rule for this chapter or session for today. Alright, so what we are going to do is, suppose you are given this function, how do you differentiate? We say this is a product rule. So say first prime or prime. When I say prime, I mean differentiation. So I'll say what you do is you have two things there. Alright, so what you are going to do is the product rule works like when you have a b like that, the dy dx of a b will be a, then b dy dx of that b, plus again you differentiate the other, then you maintain the other one. So that's how it goes. Alright, so now what you are going to do is same case for this one. So what we mean is you differentiate the first one, let's say u, then you maintain v, plus again you differentiate what, v, then you maintain u, just like this. So that's the formula you saw on this page here. Alright, that's how it came about. So now what you are going to do is we'll actually drive this formula, and from there I'll give you just the shortest trick that you can use, or I'll just go direct and give you the shortest, because no one will ask you to drive. Alright, so let me just give you the trick then. Alright, so in coming up with this, get me clearly now, in coming up with this theory or just solving questions that let's say you are told to differentiate, let's say y is equals to b, alright, a b like that, then you are told to find, let's say, y prime 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 prime. Alright, that's 3, even 4 or 5, just like that. Alright, of this b. So how do we differentiate this one? With just a simple method. Well, this is why we are here to tell you now. So what you do is, you remember how we used to do Pascal triangle. Pascal triangle could move like this. Alright, 1, you put 1 1 there, so this 1 1 will add to give you what, 2. Again this you put outside, you always put 1 1 outside. Alright, this 1 and 2, they'll give you what, 3, and also here they'll give you what, 3. Alright, then you keep on writing 1 1 there. Right, again here you give you what, 4, then here is what, 6 between these two. Alright, this one and this one is 6, then this one and this one again is what, 4, like that. So you maintain 1 1 outside. That's Pascal triangle. It's a triangle you have seen. So now what you are going to do is, using this triangle, so when you have anything differentiated giving you 1, once you differentiate that thing, that just know that it has what, power 0. So we'll start writing 0. Alright, this one, when it gives you like that, you start writing 1, then this one give you what, 2 3 4. That's the reason why. So this is the fourth okay, this is the fourth derivative, or this is the fourth. Take in consideration like this is what, take as if this is the binomial expansion. Alright, but there's just slight thing which changes. Alright, so this is the fourth derivative that we use. Alright, so we'll get this one if I want to find d4. Let's say I'm told to say the function is what? Y is equals to AB, right? Then I'm told to find the what? Y to the power 4, or 1, 2, 3, 4, like that. Okay, so how do I find this? I'll bring these all right. So suppose I'm told to find the dy dx of let's say y is given as what? Y is given as a b, like that. Okay, then I'm told to find y prime 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 4. All right, so what I'm going to do is I'll go on the fourth, right? This is my fourth one. So what I'll do is I'll write 1, all right, I'll write 4, I'll write 6, I'll write 4, I'll write 1. All right, so what you do is the first thing you put here, there are 4, so meaning that the 1 should have what? At least the highest power of 4 prime. All right, so I'll put a and b here, right? A and b. So I'll choose b if I want. You can choose a. So I'll put what? 1, 2, 3. All right, that's 4, like that. Okay, then here again I write what? A b. All right, so now if I write a b like that, it does like the other one is changing. I mean, the other one is increasing, the other one is what? Decreasing, like that. So for a now it will have what? First derivative. Then for b now it will have what? 1, 2, 3. It has reduced by what? By 1. So again at this point, so this is plus, by the way. Again here is plus, by the way. So again I'll write the same a b, like that. Okay, so if again, since a has reduced, so a is increasing to what? To 2, like that. Then b is also increasing what? To 2, like that. Okay, then at this point now a will have 3, 1, 2, 3. Then b will have what? 1 prime. Then at this point now a will have 4 prime, so 1, 2, 3, 4 prime. Then b will have just like that. It will be just, you maintain the same b the way it is. So these are the plus. All right, so there's plus there and also plus. So that's how you find the fourth derivative. You just go on a Pascal triangle, you get those, then you come now and what? Start substituting. So what you do is first you say a and b, you do this. So before even substituting in your equation, you say a and b, like that. So you say a so a prime, you put like that, you find the value there for that number. Again a prime second prime 2 prime, you find again the value. Again a prime prime, all right, prime, you find the value. Again a prime 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 prime, you find the value there. Then again for b, you do the same. B prime, you find the value there, and also you maintain the b, the way the value of b and also the value of a, like that. Then you start differentiating one by one until to the highest power of 4, because you are told 4 each should have what? The highest power of 4. All right, so what you are going to do is we'll differentiate and we'll get the value there. Again we'll differentiate b prime prime, then we'll get the value there. Again we'll differentiate b prime prime prime, then we'll get the value. Again we'll differentiate the final one, b prime prime prime. What you have, we should have at least to the what? To the at least you should have to the each of those product of those two functions you have there on your question. Make sure that they lead to that specified n or number of derivatives each. So like this I've reached 4, and also here I've reached 4, so I have the value there. Then the issue will be just pressing in there. All right, so that's about it. There's nothing much about Leibnitz equation whereby n is specified, and we'll go through this question. So we'll solve this question and also solve this question. You'll be able to see that, oh, this is simple. All right, so I didn't want to show you the way it came like that, but you keep on the same. No one will ask you, but this is the right way to do things. So simplified, easy stuff, right? So so what you are going to do is, suppose you are given a question now to say y is equal to, let's say y is equal to x to the power 3. All right, this is from your question paper, one of the question paper. Then this is what? E to the power x like that, 2x like that. We know how to differentiate this one, and we know how to differentiate this one. So we have a and b, so we choose as either being a, v, or u. All right, so I can choose this one as let what, let u be equal to what, x to the power 3, and v be equal to what, e to the power what, 2x. All right, so what you do is, now the first derivative of u, so you say u prime, what you differentiate is this one, 3 times that would be 3x squared, right? Then again you differentiate the same y prime, so it will be times that, then it will come where, this is what, 6x like that. Then again you differentiate, all right, so again you differentiate, all right, the power 3 like that. Okay, so before I even tell that, so I'll say, can you find what, so this is the question. Then we are finding what, find, I haven't given the question, so we are told now to say find d, d3 y d what, x3 like that, of this y we have. Okay, so this is where now we are coming in to work on this one. So the last should be 3. Okay, so that's d3. So now I'm going to write what, 6 there. It's a constant. That's when you differentiate this one, you get what, you get 6 like that. Okay, so from there what you are going to do is to differentiate this one. So the first derivative there of this one okay, so the v derivative first, it will be, you multiply what is we know how to differentiate exponential function. So you differentiate what is on top there, then you multiply times as the coefficient. So what you do is, in case you have forgotten to differentiate it, you differentiate this one, then you multiply there, then this you maintain the same way. So it will be 2. All right, you the dy dx of 2x is 2, then you maintain the way it is. Again you differentiate just like that. It's a chain. All right, hope that is clear. So that's how we'll be differentiating exponential functions. All right, so what you do is you differentiate what is on top there, you get what, so once you differentiate what is 2x is what, 2, so you bring 2 as a constant, then you keep this e, then you maintain the same 2x there. All right, so again v prime prime, then you differentiate that one, that will give you what, 4 e to the power, the same thing. All right, so then again you differentiate what, e to the power what, 3 like that, then that will give you what, that will give you 8 e to the power 2x. We are done here. This is the maximum we can have for v and for u. So then now the only thing which we have remained with is to write the Pascal triangle. Pascal triangle will be going as follow. All right, so you bring Pascal's triangle. You said this one is what, Pascal triangle will be moving as 1 1 there. All right, they will make 2, then we put 1 there outside there. Again this they will make 3. 1 plus 1 is 3. Again 2 plus 1 is 3. Then you put 1 outside there. All right, it's a game. Then again here it's what, so this is to the power, you start with 0 1 2 3, so we have reached 3. All right, so that is 3. So you start at 0, then you come down just like that. That's the reason why anything to the power 0, the dy dx is what, 1. It's 1 there. Okay, so anything to the power 0, the dy dx is what, it's 1. That's the reason why we are following this Pascal triangle with such conditions. So what we do is, this is now which has what, been successful. All right, so 3 3 1, okay, for the third derivative of n function. So what I'm going to do is, I'll choose any letter a, b, or just v, anything. They will still result in the same thing. So what you do is, you say, I can choose even writing I can choose writing what letter, I can choose writing u, I maintain u there, then I write what, v to the fullest differential, which is n, that's c to the power 3, that's d3, right? Then here this u now will increase by 1, then the v now will increase by what, the v will increase by what, will reduce by 1. All right, so remain with 2 of them. Then here the u what will increase by 2, right? Then the v would remain by 1. So here the u will be what? Will be increased by 1 again to make 3. Then the v will remain what? Just like that normal v, all right, which is normal function. All right, so this is how you write dy dx of specified number of n, and what you do is you say d3y over what? dx3, like that, is equal to that. Okay, so here there are plus there, and also there's a plus there, and also there's a plus there. Okay, so from there then what we are going to do is we'll say we'll write like that. So say 1 there, all right, open bracket. What is u? U is what? X to the power 3. So you write x to the power 3, open bracket, close. What is u prime 3? All right, so u v prime 3, this is the one, right? So you write 8 to the power e 2x, like that. Okay, I don't think the space will allow me, so this is a small space that I have. Okay, yeah, let me just lab. All right, let me start from here so that I know the space will be very long. So I'll say the d3 now over of y over d what? x3, like that, is equal to, here I substitute, there's 1 there, right? Open bracket, u is constant, so u is what? X to the power what? 3. Okay, then again the v now, v prime prime prime, this is now what? H to the power what? This is the v prime prime prime, so you substitute, so you write what? X to the power 2x, like that. Okay, then plus, all right, plus there, then 3, open bracket. What is u prime? U prime is what? 3 to the power what? U prime is there, so that is what? 3 to the power what? 2x, x squared, like that. Then what is u prime prime? So u prime prime is what? Is there, so that is the 4 e to the power what? 2x, like that. Okay, then plus, again you write 3 there. Okay, u prime prime, u prime prime, so u prime prime is 6x there, you can see is there, so you write what? 6x, like that. Okay, then u v prime is, it was what? V prime is just what? Is this 2x, 2 exponential 2x, something like that. So 2 to the power what? Exponential to the power what? 2x. All right, natural log of that. Then open bracket, then plus, you write 1, open bracket, u prime prime prime, so that's what? 6. Then v is what? Is just e to the power what? 2x. All right, so this is the answer that we are almost getting. So you multiply now. Okay, so this will be x to the power 3. No, that is 8. 8 should be in front there. We are grouping just the right terms. We are now simplifying. We are done with the work. So what we do is we write 8, because 1 times 8 is 8. All right, x to the power 3, then e to the power 2x, like that. Then plus, all right, we multiply. What is 3 times 3? That's 9. 9 times 3. What is 9 times 3? 9 times 4, I mean that 36. 18 plus 18, 36. So say 36. All right, so 36, then we have what? X squared, then e to the power what? 2x, like that. No, yeah, 2x, like that. Then plus, again plus, you multiply now. What is the 3 times 6 times 2? All right, so that will give you what? 24, right? So no, 18. 18 times 2 is 36 again, so we'll have 36. So 36 x, which is this x, then we maintain what? The same 2x, like that. Then plus, okay, plus, we have 6 times that, that is the just 6. All right, then to the power what? 2x, like that. So this is the final answer. We are done, guys, but what I can do, I can simplify something here. 6 I'm sure is common. No, 6 is not common, but e to the power 2x is common, so I'll say e to the power 2x. just to show them that I can do things. So here I have what, 8x cubed, then plus here I'll have what, 36x, all right, squared, then plus 36x, then plus what, 6. All right, so I'm done just like this. So this is the answer that you needed to write in your exam. So this question came in one of your paper, guys. Bank 2. Okay, this is engineering mathematics. Then the other question that we can solve again is the one from our question paper. Okay, this is the one. So we'll also do this one. All right. Okay, so that's how you can do. So suppose you are given the function y is equal to x to the power 5 cos 2x, like that. All right, so we are told now to find so we are told to find what, d 4y over what, dx 4, like that. Okay, of what, of this y we have there. Okay, so what we do is you bring the same thing there. So we are going first to differentiate these two guys. So you choose, I can choose to say u is equals to what, I can choose u is equals to what, 5 to the power, I mean x to the power 5. Then I can choose v to be what, cos what, 2x. All right, so I can now start differentiating. So what is u prime? So I'll go to the highest what, 4, because they have specified the n as 4. So I'll go for u, I'll go to the highest what, n as 5, and for v I'll go to the highest n as what, 5. 4. The d4 is the d4, guys. So what we are going to do is that if I differentiate this one, I'll have what, 5x to the power 4. All right, so if I have what, y prime prime, then I'll have what is 4 times that, you differentiate that one, it will give you what, 20x to the power 3. You differentiate that one, it will give you what, it will give you 60x squared, right? Then you differentiate that one, the last one now, which is to the power 4. All right, that will give you 120, then x, just like that, right? We are done. So we go also for v. So v prime, it will be, so let me just teach you one trick. Let me teach you one trick. Whenever you're differentiating these we know cos is always lying on the x-axis, then sine is always lying on the what, so this is negative sign, this is what, no, that's positive sign, this is what, negative sign, like that. Then this is negative cos. All right, so now the way you differentiate clockwise is dy dx. All right, so when you differentiate positive sign, you get cos. You differentiate negative sign, you get negative what, cos. You differentiate just like that, so rotation continue like that. All right, so dy dx goes down there. So this is how what, then integrating is the opposite. Now you go anti-clockwise using this trick. So what you are going to do is, once we differentiate, when you have a trig function, so you have, let's say 2 sine what, 2x, like that. What you do is you first differentiate the angle, then differentiate the whole thing. You see, differentiate the angle, then the whole thing with the angle. So what I'm going to do is I'll differentiate this 2x. So by the way, let me just light this so that you don't get lost. So differentiate the angle. All right, so when differentiate the angle, you get what, 2. All right, then differentiate cos. Okay, what is the dy dx of cos? You can see is giving what, negative of this angle. All right, so I will say this is negative. It won't make sense me lighting negative just like that. I need to put negative in front so that what I see, we have grown up. So I'll put that negative of sine, then that's why I differentiated from the angle, then I put now the sine with the same angle. All right, so that's how you differentiate trig functions. So again, second derivative of this v, it will be, you differentiate again the same thing, right? You differentiate this to there. All right, so once you differentiate this to there, all right, so we'll go now and differentiate what, we'll go and differentiate what sine, just sine like that. So so I'll say that is now it will be 4, right? 4. Then sine x is sine something, sine dy dx of sine, let's say this is x, sine x is what, dy dx of sine x is cos, so I'll just write cos there. So again I'll come to what, you see, so that's how it moves. Then again v prime like that, you differentiate this one, that to give you got negative what, 8. Then differentiating cos and that will be what, negative sine, because you differentiate cos, you come to what, to negative sign, so that will be positive, right? Positive. Then cos what, that's sign, by the way, is it gave me sign negative sign, but because of the other negative I had, I have to write what, positive. So now this is what, sine 2x like that. Okay, so v prime 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 is equal to what is v prime prime prime? So what you are going to do is, again, you differentiate this one, this will give you what, 16, right? But sine, you differentiate sine, you get cos, so that will be just positive cos the same angle. All right, hope this is clear, guys. Hope we are not leaving anyone behind. Hope this is clear, guys. Okay, so from there then we are done with everything. Now let's go to our data. Pascal triangle for the fourth derivative. All right, we'll start with 1. All right, we said you write 1 1 there. All right, then you add this 1 and 1, you get 2. Then you put 1 again outside, again you add this between, you get what, 3, right? Again 3 there, right? Then you write 1 1 outside there, again you write what, we are going on the fourth derivative. All right, so then okay, so here, there and there, then it will give you what, 4. All right, then you write 1, then here to give you 6, then you write what, 4 there. 1 plus 3, that's 4. Then you are done. So this is, we said this is the 0, then 1 2 3 4. So that's how they move. Okay, so this is the fourth derivative we want. So the successive chan dy dx is what, is the let me just write it, 1 4 6 4 1. All right, so that's a successive Pascal triangle we have from the fourth derivative of any specified function with the n when it is specified like that. Okay, so now we are saying that is what, 1 4 6 4 1 like that. Okay, so what we do is now we are going now to substitute those values, like dy dx of what, fourth derivative. So fourth derivative will have the dy dx as follow. So the dy dx, so fourth d4 over d what, dx4 is equal to, you bring this one, right? You choose any of those letters, v and u. So I like choosing u to be just the normal, then v continues with the 4 things there. All right, so that's fourth derivative of v, then plus 4, then the u now will have what, 1, then the v will have what, 1 2 3 like that, then plus 6. All right, the u now will have what, 1 2, then also the v will reduce by 1, that's what, v1 2 like that. Okay, then plus 4 like that. So here the u will have what, 3, then the u will just be have 1. So here plus, this is 1 by the way, so under this one the u will have now 3, then the v will just remain like that. So no, the u will have 4, then the v will just remain like that. All right, hope this is clear. So what we do is now we say now dy d4, or just now therefore d4 dy is equal of dx4 like that is equal to what, you just substitute there, guys. Now we just substitute, that's our work. All right, so what we do is we are going to substitute in there. So the way we substitute is we write that constant, then times the u is what? U is the x to the power what? 5. All right, times what is our v prime 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 prime? That is what? 16. That is v to the 4th prime. So we'll write 16 cos 2x like that. All right, then we are done with the first one. Though we'll write plus, then we'll write again 4 open brackets, two things. First derivative of u, that is what? So here guys, we are here. So first derivative, that is what? 5 the power of u, that is 5 to the power 4. Then what is the derivative? That is now the third derivative of what? U, v. So the third derivative is z 8. So this is the third derivative. So you substitute. It's just a matter of substituting. So this is 8 sine what? 2x as the angle. All right. Then from there, what you do is we are done with this one. So we go on the 6. So 6, we have u prime prime. U prime prime is what? 20 to the power what? 20x to the power what? 3. Then what is now u prime prime again? So u prime prime again is what? I mean v prime prime is what? Is this one there. So that would be negative what? 4 cos 2x like that. Okay, then we are done with that one. Then plus, what is the 4 open bracket u prime prime prime? So that's the third prime of u. So that is 60 what? X squared like that. Okay, then what is v prime now? V prime is just negative what? Negative negative 2 sine what? Sine 2x, the angle there. Then we are done. Then plus, all right, what is the that's 1 now open bracket. What is u prime 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 prime? So fourth, that's 120, right? That's 120x open bracket. Then you give also the v now, the v normal, which is cos 2x. All right, so that's cos 2x. So it's just a matter of multiplying now. What is the 1 times 16? All right, 1 times 16 is what? 16. So we just write 16 there. All right, that x to the power 5 will remain. Then we bring the trig function, which is cos 2x like that. Okay, then plus, what is the 4 times 5 times 8? That is 160, right? So you write 160. That is x to the power what? 4. All right, x to the power 4, then sine what? Sine 2x like that. Okay, then plus, what is 4? That's negative. I can see a negative, by the way, before I even reach very far. That's negative. Negative times 20, I mean negative 4 times 20 times 6. What would be that? That is 480. All right, so that would be negative 480 like that. Okay, so we have cos 2x like that. Okay, then the other thing that we can have is we are done here, so we are going here. All right, so we have 4 times 60 times negative 2. All right, so this should be the same case again. So there's also a negative there. Okay, so there is also a negative there on 2. So that would be a negative. Okay, so that's a negative, right? So we write negative like that. Then plus, so that is the same thing, negative 480 like that. Okay, so negative 480, that is now x what? X is to the power what? Okay, x is now to the power what? Negative 2 like that. Then we have what? Sine 2x like that. Okay, allow me just to be putting the what's this in the angle. I'm done here. Then the last thing that I can write now is we multiply now. We multiply what is the 120 times 1, which is just cos. So in short, 120 times 1, that's just 120 x, then cos what 2x, like that. So that is it. Thank you very much, guys. This is done. Like, we are done. This is the answer. All right, the fourth derivative, or just the dy dx to the power 4. So the next topic that you are going to do is so you can try out these ones. So you can try out this one. Given that y is equal to what, e the power 3x, all right, sine sine, let's say 8x, like that. Okay, so try this one. And also, given that, so this is the second one. So given that y is equal to x the power 3, then sine squared 3x. all right, so that is it. So when you have sine squared, let's say sine squared 2x as the angle, this is just a what's this, this is the sine, all right, 2x, all right, to the power what, 2. So what you do, you know what to use here. Use what we call now what, chain rule. All right, so what the way you use chain rule now, you multiply this one. So to find the dy dx of this one, let's say it's a y, so the prime of this one is b. These two you multiply on front there, then open bracket, you differentiate what is inside, right? You differentiate the whole thing what is inside. That is what, you know what I mean. So that's how you differentiate that. Okay, so those are the answers, I mean exercise. So you can send the answers to the line. So the other one, again, let me give the third one. So you say y is equal to y is equal to, all right, y is equal to, okay, let me just give you x the power 3, then e to the power what, x, like that. So you find each of them, like you find here you find y prime prime. Here just find y prime prime prime. No, that's, yeah, okay, just like that. Then here find y prime prime, like that. Okay, so send the answers to the line 0970200920. So if you send the answers, then you'll be part of our learning team. So you'll be joining us every day. Thank you very much for watching the video. Please subscribe. So the next thing that we'll do is, when you are not given the n, when you are just told, let's say, find the nth derivative, all right, nth derivative. So that's the simple stuff, and that's where we need to pay more attention. All right, so thank you very much for watching the video. Bye, see you.